Okay, good morning, all. In today's lecture, we are going to discuss with related to the stainless steel. In last lecture, we have discussed about the tool steels and different types of the tool steel. That is, we have learned about cold worked tool steels, then hot worked tool steels, high speed tool steels, and special purpose tool steels, and their different types. And for each type, we have discussed their composition, properties, and their specific applications. Now, in this lecture, we are going to deal with the stainless steel. First, we will start with the why these steels are termed as the stainless steel. Then, what are the properties of the stainless steels? And then after that, we will move towards the general composition of the stainless steel. And after seeing the general composition of the stainless steel, we will move towards the classification of the stainless steel. And for different classification, what is their composition, and what are their properties, and what are the applications for different type of the stainless steel that we are going to discuss in this lecture. Now, first we will start with the why this name is given as the stainless steel. Okay, because these steels, as I have written that in the first point of this slide, these steels have very high corrosion resistance. Then now here, what is the corrosion resistance? A resistance provided by the material when any material comes in contact with the any certain type of the chemical or any oxidizing material, means due to that chemical the material will get removed. Okay, particle from that material. Suppose there is one steel component, and when it comes with in contact with the any oxidizing agent or any chemical, then slowly that came as time passes away. We will see, take some practical example. Suppose one ship is there, and that ship material, or it is made up of, suppose, some steel, that outer body is made up of the steel. When it comes in contact with the seawater, now seawater is highly corrosive in nature. That is, it consists of the sodium chloride solution there, and that is highly corrosive in nature. Whichever material comes in contact with the seawater, slowly that seawater will try to corrode it. Means corrode means it will try to remove the surface particle from that material. But uh, these stainless steels will provide, or they do not get corroded when it comes in contact with any kind of the chemical or certain environmental conditions. There is means it does not get corroded. That's why the name is given as stainless steel. Okay, I will repeat it again. Why these steels are termed as stainless steel? These steels have very high corrosion resistance, and high corrosion resistance means, and they does not get corroded when they comes in contact with the any chemical environment or any corrosive environment. That's why these are termed as the stainless steel. Now, why these steels are providing the properties like high corrosion resistance? Now, this high corrosion resistance of the stainless steel is due to the presence of the chromium. Due to the presence of the chromium. Now, what happens here? This chromium may present in the two ways. That is, chromium will get reacted when chromium is added in the steels. Then that chromium will get reacted with the carbon present in that steel, and they will form the chromium carbide. And remaining amount of the chromium, it will form the solid solution with the iron. Now, whenever amount of the chromium in the form of solid solution is more, then that material or that particular steel will be having more corrosion resistance. Okay, please take note of this point. That is, whenever amount of the chromium. Now here, this stainless steel has a very high corrosion resistance due to presence of the chromium. But here one condition is there. Whenever chromium is present in the form of a compound, that is, suppose, chromium carbide, it does not improve the corrosion resistance. It should be present in the form of a solid solution. Okay, now that condition gets satisfied in this stainless steels. that is whichever larger amount of chromium is present in the form of solid solution. Now, what this chromium does during the process means how it improves its corrosion resistance. Whenever that stainless steel material is exposed to the oxidizing environment or any chemical, then during that chromium will get reacted with the oxygen and it will form chromium oxide, and that the thin layer will get formed on the surface of that stainless steel material. Okay, now whichever chromium oxide layer is formed, that layer will be passive, means it will be neutral in nature, then it will be self-healing, and uh, it is impervious to the further attack. Impervious means, in what you can say that मराठी मध्ये त्याला काय म्हणतात, इट इज इम्पॉसिबल टू ब्रेक, और आपण काय म्हणतो मराठीत अभेद्य असं काय तर वर्ड आहे त्याला, म्हणजे आपण जे ब्रेक करू शकत नाही त्याला आपण काय म्हणतो, इम्परवियस. ओके, विच एव्हर फिल्म इज फॉर्म्ड हियर, that chromium oxide film, it is passive. Passive means it is neutral in nature, it does not react with the any other material which comes in contact with it. Then it is self-healing, it will try, whichever amount or loss of that film will occur, it will try to form one layer again and again, and it will be impervious in nature, that is it is not possible to break due to the other chemical presence or other chemicals surrounding that particular kind of the steel. Okay, in this way, due to the formation of this oxide layer, that is chromium oxide layer, when that stainless steel material comes in contact with oxygen, this chromium oxide layer will provide the resistance to the corrosion. Okay, whichever corrosion resistance is provided by the stainless steel material is due to the this chromium material or chromium element. That chromium will get oxidized and it will form a chromium oxide layer on the surface of that steel, and due to that layer only it will provide the very high corrosion resistance. Okay, in the we will move towards the next slide. Now, here the general composition I have mentioned for the stainless steel. Now, whichever as already I have discussed related to this, to provide the very good corrosion resistance, that the chromium should present in the form of solid solution. Now, whenever that presence of chromium in the form of solid solution is greater than 13%, then it will provide the better corrosion resistance that I have highlighted in the first point. For you can read it. For sufficient corrosion resistance to have that stainless property, in the most general type of the environmental conditions, the minimum amount of chromium in the solid solution form should be greater than 13%. Okay, now I will explain this. Whenever we are adding the chromium initially in the steel, that chromium initially will combine with the carbon. Okay, whichever amount of carbon is there, it will combine with that chromium. Then how much amount of chromium will combine with the carbon? Now, whichever amount of carbon is present, then 17 times of that carbon amount, that much chromium will get combined with the carbon. Suppose in this particular steel we are having 0.1% or suppose 1% carbon. I am taking just example for understanding. If 1% carbon is there, then suppose you have added the chromium, then 17 times of that carbon means 17% chromium will combine with the carbon, and remaining chromium will form the solid solution with the iron. Okay, so in this way, any general steel will contain the amount of the chromium. Means whenever chromium is added initially, then whichever amount of carbon is present in that steel, 17 times the carbon, that much amount of chromium will combine with the that much amount of chromium will combine with the carbon. Here I have mentioned it, that is 17 times of the carbon, means this much amount of chromium will form the chromium carbide. Okay, this much amount of the chromium will form the chromium carbide, and remaining amount of chromium, it will be present in the form of solid solution. Okay, this is the formula to calculate the chromium in the form of solid solution. That is total chromium minus the chromium which reacts with the carbon element, and that amount will be 17 times the percentage of the carbon, and remaining amount of chromium will be present in the form of solid solution only. Okay, just what you have to remember here, whichever chromium is present in the form of solid solution, its amount should be at least 13% or greater than that 13% to provide the higher amount of the corrosion resistance. Okay, and the general composition will be, generally the stainless steels are alloys of iron, carbon, and major alloying element will be chromium here. And with this, along with this, certain elements like nickel, certain elements like nickel, manganese, molybdenum, titanium, then tantalum. This Ta is tantalum element. Okay, these alloying elements may be added depending on our need. Okay, this is the general composition. Stainless steel is alloy of the iron and carbon, and chromium will be major or principal alloying element, and some other alloying elements like nickel, manganese, molybdenum, titanium, or tantalum, they may be added depending on the desired properties. Okay, and whichever amount of chromium is added, in that 17 times of the carbon. Okay, suppose 1%, I'm repeating this point, that is, suppose you have added the chromium, then whichever percentage of carbon is there, suppose 1% carbon is there, then 17 times of that carbon percentage, that is 17% of the chromium, it will react with the carbon directly, and it will form the chromium carbide, and the remaining amount of the chromium, it will form the solid solution with the iron. And whenever the percentage or amount of the chromium in the form of solid solution is more, then and then only it will improve the corrosion resistance of that particular stainless steel. Okay, so this is the general introduction for the stainless steel. Why these types of stainless steel, why these types of steels are termed as stainless. Stainless means it does not get corroded when exposed to the oxidizing environment or any chemicals. It does not get corroded, that's why the name is given as stainless. Okay, and that particular steel will be termed as stainless steels. Now, after seeing this, why the name is given as stainless steel, then what is the role of that chromium? We will move towards the next point, that is the properties of the stainless steel. Okay, here are the properties of the stainless steel. Now, the first property already I have explained it. It is a high corrosion resistance due to the presence of the chromium. Okay, and they will provide the high corrosion resistance. Whichever chromium is present in that steel, it will get oxidized, and it will form a oxide layer, that is chromium oxide layer, and that chromium oxide layer will be passive, then self-filling, and impervious in nature. Impervious means the layer which is impossible to break. Okay, almost impossible to break. But if more chemicals are there, sometimes it may get break. Okay, but depending on the amount of the chromium, that corrosion resistance of the different alloys will be different. Okay, depending on the amount of chromium. Suppose one type of stainless steel is having lesser amount of chromium, then it will provide the lesser corrosion resistance. If a particular stainless steel has a more amount of the chromium, then it will provide better corrosion resistance or higher corrosion resistance. Means this corrosion resistance properties of this stainless steel will vary from the alloys to alloys. Means depending on the composition or content of the chromium, it will change. Okay, for different stainless steel, this corrosion resistance will be different. Now, these stainless steels are generally containing the carbon percentage or lesser carbon percentage will be there. In commonly, the stainless steels are low carbon steels. In carbon percentage will be less than 0.3%. Okay, from starting from 0.008 to 0.3%. These are having very low carbon percentage. Due to this low carbon percentage, what will happen here, these stainless steel will provide high ductility and high formability. Okay, already we have discussed this point. Whenever amount of carbon in the steels is the lesser, that is, it is a low carbon steel, it will be providing very good ductility, formability. Then you can read this point, it will also provide very good weldability and machinability. Okay, due to the lesser percentage of the carbon, they will be having very good weldability, machinability, and ductility and formability. The next property you can read this third point, that is, they will provide very good mechanical properties at the lower temperatures as well as the higher temperatures. Here mechanical properties, in the sense you can say that they will provide the very good strength at the lower temperature as well as the higher temperatures. Now, why this strength is provided here, good mechanical properties, why the stainless steels are having very good strength? Now, as already I have discussed, that whichever amount of chromium is added, initially it will react with the carbon and it will form the chromium carbide. Due to presence of this chromium carbide, that chromium carbide is hard in nature and it will improve the strength and hardness of that particular steel. That's why they will be having good mechanical properties, that strength, hardness will be good at low as well as at the higher temperatures. Now, the next property will be high resistance to the scaling and oxidation at the elevated temperatures. Now, here this resistance for the scaling. Now, what is the meaning of the scaling? Scaling is nothing but loss of a material from the surface due to the means when it comes with the contact with the air. Whichever loss of the material is there, when that material comes in contact with the environmental air, that will be termed as the scaling. And certain oxidation will be there, means when that particular elements from that steel comes in contact with the oxygen, that oxidation will be there. Then it will provide the, initially it will get oxidized. Okay, initially that steel, chromium will get oxidized from that steel, but after formation of the layer of that chromium oxide, that oxidation will get stopped. Okay, means it is having high resistance to the scaling and oxidation at elevated temperature, means at the higher temperature ranges also. Then good weldability, machinability, already we have discussed. Then good creep resistance, it will provide very good creep resistance, means the resist the creep resistance will be very good. Already we have discussed what is the meaning of this creep resistance also. Then the next point is the, as you have seen the different stainless steel components to your surrounding, you have already known to fact that the stainless steel components are having excellent surface finish and they are having very attractive appearance. Okay, very good appearance will be there for this stainless steel material, and that you can write in the properties of this stainless steel components. Okay, so these are the certain properties and depending on the elements present in that stainless steel component. Okay, after understanding the what is the meaning of stainless steel, then understanding their general composition and their general properties. These are general properties of the stainless steel. Depending on the different types and different composition of that stainless steel, this property may be different in different kind of stainless steels. Okay, depending as their composition varies according to their types, some property may get changed. Now, the next point in this is the classification of this stainless steel. Okay, classification of the stainless steel is depending on the whichever phases present in that at different temperatures in the stainless steel, depending on their composition and depending on their temperature. Different phases may be there at the room temperature and at the higher temperature ranges. Depending on that, these stainless steel components are classified in four types: Group A, then Group B, Group C, and last is precipitation hardenable stainless steel. Okay, this Group A is also termed as martensitic stainless steel. Then this Group B is also known as ferritic stainless steel. Group C is also known as austenitic stainless steel. And the last type is a precipitation hardenable stainless steel. Okay. Now, depending on which basis this classification is done, this classification is done on the basis of, you can say that there will, depending on their phases at the, suppose at the room temperature or at the higher temperature ranges, whichever phases are present, depending on that, these names are given. Please note this classification of stainless steel. I'll wait for 1 minute here, just write down the names. Okay, now after completing this classification of stainless steel, we will discuss each type in detail, means they're related to their composition, properties, and application. We will start with the first one, that is the Group A. Group A stainless steels. These stainless steels are also known as martensitic stainless steel, and generally these are denoted by AISI 400 series. Okay, now what is the meaning of AISI 400 series? That we are having the separate point related to that. Here, just try to understand. I will tell you the just long form of this AISI, that is American Iron and Steel Institute. Okay. In the next lecture, we are going to discuss about that specification of the steels. Okay, specification, or in short, you can say that nomenclature. Also, you can term it, means how the naming is provided. That we are going to discuss in that. But in short, what you have to remember here, each specific stainless steel is classified in the groups. Okay, that AISI 400 series. Now in the you can see in the second slide, the group B also comes in that AISI 400 series, but group C, it will come in AISI 200 and AISI 300 series, like this. For different groups, they are having different AISI series. These series are, in short, I will tell you that these series are depending on the different compositions or different elements present in that. Okay, now We will start with this group A. These are also known as martensitic stainless steel. Okay. Now, generally, this group A or martensitic stainless steels generally this group A or martensitic stainless steel, these are alloys of iron, carbon, and chromium will act as here principal alloying element. Now, as already we have discussed that chromium is present in the form of solid solution and chromium may present in the form of compound. It means that chromium carbide. Now here, as here I have mentioned that the chromium chromium in the solid solution form in this particular group A is less than 13%. Okay, your amount will be less than or almost equal to the 13%. Means chromium in the solid solution form in the group A is less than 13%. Now, the general composition here I have mentioned that in this group A stainless steel, the amount of chromium varies in the range from 12% to the 18%, and amount of the carbon will be in the range 0.15 to 1.2. But generally these steels are having very low amount of the carbon. Okay, almost 0.15, 0.18, 0.20, less than 0.3 carbon will be there. In some special cases carbon percentage will be higher, that's why I have mentioned the range. But you have to remember that they will be having lesser carbon percentage only. Here one example I have taken for the purpose of the composition, or you can write the general composition also. That is, this is the alloy of iron, carbon, and chromium with 12 to 18% chromium and 0.15 to 1.2% of the carbon. Now, just for example, I have taken here one steel, that is 4110 steel, AISI 410 steel. It will consist of the chromium from 12 to 14%, and carbon will be less than 0.15%. Okay, so this is the general composition. You can write in this like that. These group A stainless steels are generally alloys of iron, carbon, and chromium. Chromium will act as a principal alloying element, and the chromium in the solid solution form for this type of stainless steel will be less than 13. Okay, please don't get confused in terms of the chromium in the form of solid solution and amount of chromium. Okay, you can see here amount of chromium is at the higher ranges. This is the total amount of carbon, and here I am highlighting this chromium in the form of solid solution. We are adding this much chromium, but some amount of chromium will combine with the carbon, and remaining amount goes in the form of solid solution. And chromium in the form of solid solution is here less than 13%. Okay, total amount will be more, but some amount will get combined with the carbon to form chromium carbide, and remaining amount will goes in the form of solid solution. Okay, now related to the properties, you can write their general properties. That is, they are having very good corrosion resistance, then very good wear resistance. Then these are magnetic in nature and having very good strength and hardness. Now, in the next point here, I have mentioned that why this name is given as martensitic stainless steel. Now, these steels will have austenite phase. Here I have mentioned that these steels shows austenitic phase, means austenite phase at the higher temperature, that is indicated by the letter gamma in your iron iron carbide equilibrium diagram. At the higher temperature ranges austenite phase is there, and these steels can be transformed to the, or these steels can be hardened. Hardening process can be done for this particular steel by the martensitic transformation. Now, this martensitic transformation is the very detailed point that we are going to discuss in the next chapter. Just try to understand here. This is one more phase which is formed depending on the cooling rate. Suppose steel is at the higher ranges, above suppose 900 degrees Celsius, austenite phase will be there, And hardening means we are doing the quenching in from initially we are heating that steel to the 900 or 1000 degrees Celsius temperature range, and we are taking that steel component and we are directly dipping that steel component in the water, okay, cold water, and that austenite which is present at the higher temperatures, that will get transformed to the martensite phase due to the very fast cooling rate. From 900 degrees Celsius we are collecting that steel component and directly dipping it into the water. Due to that, that austenite present at the higher temperature ranges will get transformed to martensite, and due to the presence of that martensite, that particular steel or whichever material is there, it will get or it will provide more hardness, or its hardness will get improved due to formation of that martensite. This process will be termed as martensitic transformation, hardening by the martensitic transformation, and these particular type of stainless steel are termed as martensitic stainless steel. Okay, why the name is given as martensitic stainless steel? At the higher temperature ranges these steels are having austenite phase, and we are doing the hardening of these steels by doing the means by taking or directly dipping it into the water or water quenching. Due to that, austenite will get transformed to the martensite. Means hardening is done by martensitic transformation. Hence, the name is given as martensitic stainless steel. Okay. Then after this, um, some applications are there. These steels are used for manufacturing of different types of the springs, different types of the ball bearings, and different types of the walls, then razors, razor blades, different types of the surgical instruments which are used in the hospitals, then different types of the cutting tools, then different types of the cutlery items. Cutlery items means you can say that the different types of the spoons which we are using in the kitchen, that is different types of the spoons and different types of the forks or different kitchen items which you are using, that are also manufactured or made up of the this martensitic stainless steel only. Okay, whichever that spoons and all instruments are present in your kitchen, that are made up of the these martensitic stainless steels or of group A stainless steel. Then different surgical instruments, these are easy to remember. Then razor blades are there. Okay, whichever blades you are using. Okay, these are some applications of the group A or martensitic stainless steel. Then I will move towards the next type, that is group B, that is ferritic stainless steel. Again, here in the first point you have to write the composition here. Now here one point you have to take note that here in the group B, it is known as ferritic stainless steel, and it is also designated by the same AISI 400 series. Just here composition or amount of the chromium, easy to remember that here amount of the chromium is more. Okay, in group B amount of chromium is more, and as amount of chromium is more, whichever amount of chromium is present in the form of solid solution is more than 13%. Okay, this is the differentiating point for this group A and group B, or martensitic and ferritic stainless steel. In some examinations, sorry, in some examinations they have asked also differentiating points. In two stainless steel types they will provide you the names and you have to differentiate them. Okay, now here, as you can see that chromium in the form of solid solution is greater than for 13% in this ferritic stainless steel, and in the first type it is lesser than the 13%. Okay, now amount of chromium is more. Okay, in the first, in group A we have seen that amount of chromium is 12 to 18%. Here you can see that amount of chromium is 13 to 27%. In the group A it is 12 to 18%. It is 12 to 18%. Okay, and carbon will be less than 0.2. This is the general composition. Now here I have mentioned one additional point for the differentiation purpose only. That is chromium to carbon ratio is more in the group A. Whichever ratio if you take amount of chromium to the carbon, it will be higher in the group B, okay, and lesser in the group A. And one example I have taken here, the type 430 steel with 14 to 18% carbon and maximum, sorry, 14 to 18% chromium and carbon up to 0.12%. Now related to the properties here, as the carbon percentage is very less, carbon percentage is very less, maximum 0.12, it is a low carbon steel. It is a very low carbon steel, and that's why it is soft, malleable, and ductile in nature. Okay, it is soft, malleable, and ductile in nature, and magnetic in nature also. Then, as it is having low carbon percentage, it will be providing the very good formability, machinability, and weldability also. It will provide very good weldability also, and it is having very good corrosion resistance due to the higher amount of the chromium. Okay, due to the low carbon percentage, it is soft, malleable, ductile in nature, and having very good formability, weldability, and machinability, and corrosion resistance will be very good due to presence of higher amount of the chromium element. Okay, now these steels are termed as the ferritic stainless steel. Ferritic stainless steel. Or here also I have mentioned the ferritic stainless steel. Why these are termed as the ferritic stainless steel? Because at the room temperature, ferrite phase is present. Okay, from room temperatures up to the higher temperature ranges, only ferrite phase is present. Now, why only ferrite phase is there? As amount of chromium is more here, that is 13 to 27%. This chromium is a ferrite stabilizer. Okay, it stabilizes the chromium by increasing. You can refer the iron carbide equilibrium diagram. That is, when chromium amount is more, it raises the A4 temperature. Sorry, raises the A3 temperature. That A3 temperature is there, it will raise that A3 temperature, and due to raising of that A3 temperature, that amount of ferrite phase will get enlarged, or stability of ferrite phase will get improved from room temperature to higher temperature ranges. Only ferrite phase is there, only ferrite phase will be there. That's why it is termed as ferritic stainless steel. Okay, ferritic stainless steel. Then some applications here of that particular ferritic stainless steels. These are used for manufacturing of the different vessels. Okay, different vessels which we are using in the chemical and food industries, in different types of the pressure vessels, then for manufacturing of the different components which we are using in the furnace, then in the heaters, in different types of the heat exchangers, and juice carrying pipes in the sugar industries. Juice carrying pipes in the sugar industries, these are manufactured with the help of these ferritic stainless steels only. Then different types of the restaurant equipments, then architectural and automotive trims which are present there. Then pans, means different types of the restaurant equipments. There may be different types of the pots, pans in present in the restaurant. All these are manufactured with the help of this ferritic stainless steel, that is group B stainless steel. Then after this, the third type is the group C, that is austenitic stainless steel, or these are denoted by AISI 200 and also AISI 300 series. Now here you can see clearly that here amount of the chromium is the more as compared to the initial two types, that is group A, group B. Here amount of the chromium is more, and it's in its composition. Here at least minimum 24% of chromium along with nickel and manganese will be there, and carbon percentage will be very less. That is, if you are not able to remember the carbon percentage, you can write the low carbon steel. according to the range, low carbon, medium carbon, high carbon. Here it is a low carbon steel. Okay, low carbon steel with 24% of chromium, nickel and manganese combinedly, and in bracket you can write that at least 18% of chromium will be present here, at least 18%. And for example, I have taken here two examples for 200 series and 300 series. Okay, chromium 17 to 19, then carbon, the nickel, manganese and nitrogen. Okay, now whichever amount of here I am explaining it, that whichever amount of nickel and manganese, here nickel and manganese extra elements are present. Due to the presence of this nickel and manganese, this nickel and manganese are austenite stabilizers. Due to this, at room temperature for this particular stainless steel, austenite phase is there. Okay, please try to understand this point. Austenite phase is there, austenite phase at the room temperature. That's why these steels are termed as the austenitic stainless steels. Why these are termed as austenitic stainless steels? Because at the room temperature austenite phase is there. Then why this austenite phase is there? Due to presence of this nickel and manganese element. Okay, these are austenite stabilizers. This point already we have discussed in the effect of alloying element on the steels, classification of the alloying element. Ferritic and austenitic elements are there. So from that, these are austenite stabilizer elements. Some are ferrite stabilizer and some are austenite stabilizer. This nickel and manganese stabilizer means they will improve or increase their span. Austenite will be there, austenite phase will be there at room temperature. That's why it is termed as austenitic stainless steel. Okay, now we will discuss the remaining composition. That is, some additional amount of molybdenum may be added to improve their corrosion resistance or to improve the acid resistance. Then small amount of titanium, then this NB and TA. NB means niobium. Okay, niobium, and this TA is the tantalum. These are added to reduce the tendency of the intergranular corrosion. Intergranular corrosion means internal, in short, internal corrosion will occur. Due to that, boundaries will get break and grains will get separated. This tendency will get reduced of the stainless steel. Okay, then some amount of sulfur and element Se. Se means the selenium. Okay, this Se is the selenium element. Selenium, it increases the machinability of that steel, and that steels are termed as the free machining steels. Whenever in this group C element, this sulfur or selenium element is present, it will be having very high machinability. That's why they will be termed as free machining steels. Okay, free machining steels denoted by series 303F. Okay, now after seeing this composition, we will move towards the properties. Okay, due to this austenite phase, depending on that phase only you can decide the properties. As austenite is there, austenite is soft, malleable, ductile, and it is non-magnetic in nature. That you have to write in the property: soft, malleable, ductile in nature and non-magnetic in nature. Okay, and it will be more malleable, as you have discussed that ferritic stainless steel, as ferrite phase is there, it is also soft, malleable, ductile, but austenite will be more malleable and ductile. Okay, then the corrosion resistance will be also more here. Okay, this group C will be having more or highest corrosion resistance. Why? Because of amount of chromium is the highest. Amount of chromium is the more, and amount of chromium present in the form of solid solution is also more. That's why it is having superior corrosion resistance as compared to ferritic and martensitic stainless steel. And it is also soft, malleable, ductile due to presence of this austenite phase. And then they are having very low thermal conductivity. Thermal conductivity will be low, and high coefficient of expansion will be there. As these are soft, malleable, and ductile in nature, coefficient of expansion will be more. And as these are soft, malleable, and ductile due to presence of the austenite phase, these steels will be having excellent cold forming characteristics. Okay, and strength will be more at the higher temperatures due to presence of more chromium. More chromium amount is there, that's why it will provide the more strength. Due to why? Because of the, as amount of chromium increases, amount of the chromium carbide also increases. Okay, due to that it will be having more or better strength also. Then the applications, you have to mention some applications. These steels are used for manufacturing of the engine manifolds. Then these steels are used in the food and chemical plants. Food and chemical plants. Then for the manufacturing of the automobiles, these all are manufactured with the help of this Group C or austenitic stainless steels. Then after discussing this third type, austenitic stainless steel or Group C, the last type, we will move towards the last type, that is precipitation hardenable stainless steel. Okay. Now in this type of these steels generally contains in basic elements will be there, that is iron will be base metal, then carbon will be there, and chromium and nickel are the alloying elements. Along with this chromium and nickel, which are present in the form of alloying elements, some more alloying elements like this MO, the CB. CB is nothing but the niobium only. This is the old symbol of that niobium. New symbol is NB. This is the old symbol. CB is nothing but the niobium. And titanium, aluminium, copper, or nitrogen may be there in this type of the stainless steel. Some two example composition I have taken here, AISI AM350 and AISI AM355. Different compositions I have mentioned here: carbon, manganese, silicon, chromium is 17%, nickel 4%, molybdenum, and nitrogen here. Now, these steels, in this precipitation hardenable steels, here precipitation or particles of the intermediate compounds will be there. Okay, intermediate compounds are formed, and the hardness whichever present here, hardness or whichever corrosion resistance or wear resistance is there, that is due to the formation of the intermediate or complex compounds. Due to presence of these other alloying elements like aluminium, molybdenum, titanium, copper, nitrogen, like that, there will be formation of intermediate compounds, and it will, this formation will be in the form of precipitates. If you observe their microstructure, just like the dotted powder particle presence will be there, that are nothing but the precipitation of that complex intermediate compounds. Due to that, their hardness is will get improved, means they will provide high strength and high hardness even at the higher temperature ranges, about 550 degrees Celsius. Now where these steels can be used, these steels are used in the aircraft industries or in the missile industries. Okay, in the aircraft industries and missile industries, for manufacturing their different parts like skins, different types of the nibs particles are there, then bulkheads and different structural components. All these components are related to the aircraft and missile industries only. Whichever components or parts are there in this, these all are manufactured. Whichever stainless steel is present in this aircraft and missile industries, that stainless steel is precipitation hardenable stainless steel. Okay, in this way, in this lecture, we have discussed about the stainless steel, starting from why these are termed as the stainless steel, then how it is providing the very high corrosion resistance. Then after that, we have discussed its general composition, then general properties of stainless steel, and how the stainless steels are classified in four different types. That is Group A, that is martensitic stainless steel. Group B, that is ferritic stainless steel, group C, that is austenitic stainless steel, and last is the precipitation hardenable stainless steel. And for each stainless steel, we have studied that stainless steel in respect to their composition, properties, and application. So here we have completed this point, that is the stainless steel point. In next lecture, we will discuss about the specification of the steels. If you are having any query related to this, you can ask me, or if all points are clear, I will stop this lecture here. Shall I conclude? If you are having any query, you can ask me.
सर ती एक्झाम्पल लक्षात ठेवावं लागतं का?
Which compositions?
AISI AM
No,
350.
no, it is not necessary. For just information, I have mentioned it. You have to mention the general composition. जे काही जनरल कॉम्पोजिशन आहे ते तुम्हाला मेन्शन करावं लागेल. ते एक्झाम्पल लिहिले नाही तरी चालतील. Is it clear?
Yes, sir.
Okay, okay. Okay, and one more thing is that I have added all the video lecture links. Okay, on that your study material sheet, you can refer if you have missed any previous lectures. You can go through that only. Okay, you can refer that also. Okay, now I will stop here. Thank you.